Welcome, my dear students. Welcome, my dear students. And this is now we'll talk about decision making in the uncertainty situations. And we want to know what the meaning of certainty and uncertainty, just to understand it, and to understand what is the background or the theoretical background about what do we mean by certainty and what do we mean by uncertainty. Let me tell you something. Let me show it to you on the board. Just let me clean the board first. Uh, Decision making usually is taken under different circumstances because you can see tomorrow very well, but you cannot see like after 10 years how far everything will go. If you are a supplier and you want to forecast for tomorrow, that's very easy because prices from today till tomorrow will not change a lot. But the problem is in if you are talking about planning for 5 years or 10 years. In that case, expect there will be a lot of changes in the markets and the situations, and due to many variables like the economic variables, social variables, political variables, all this will affect the decision making. Anyhow, I just want to tell you what do I mean by decision making in many cases of states of nature. What do we mean by this? Okay, if I tell you now, you are in front of me and I told you how many buttons I have in this shirt. I'm standing in front of you and say 1, 2, 3, 4, 5. You have 5 buttons in this shirt. Okay, this is, we call it complete certainty. Complete, COMPLETE, complete certainty means decision maker here is able to forecast precisely because everything is clear for him. There is no fog. It's not foggy. Everything is very clear. So tomorrow I'm going to do a business. From here today to tomorrow, it's one day only. Things will never change so much. Okay, this is complete certainty. The other side of this map is complete, COMPLETE, complete uncertainty. 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 Actually, the situation here is different. Situation here that you are in the long run, like after 10 years, 7 years, 8 years. And you cannot see, it's not foggy, it's quietly, you cannot see anything from behind, or you cannot see anything because it's in the long future and things are like exactly now when I stand at the edge of the road or on the cross the intersection. I'm far from you about 1 kilo, and I told you how many buttons are here. In that case, you're telling me I don't know. I hardly can see you. So you're asking me about the buttons? How I will see your buttons? Then in that case, it is complete uncertainty. Complete uncertainty. In between them, and this is always the decision, the focal or the pillar or the center of the decision making in business, we call it risk. Risk. And usually for the risk, we put a probability distribution. Probability. And we use even this word when we are talking, we say probable. Probably, we say it like this. Probability, which is in between those two areas. So we have complete certainty, we have complete uncertainty, and we have risk. What we will do here, we will give the decisions probability distribution. As an example, if it rain, I will come to you today. Like if it is not raining, I will come to see you 70%. But if it is raining, if it is not raining, I will come to see you 70%. But if it is raining, the rest means what? 30%, because all must equals 100%. All must equal raining and not raining. They both must equals 100% because this we call states of nature or the states of nature. Again, I won't say here that the decision is always made under three circumstances or three states of nature or three conditions of the market and the values of the market, the differences, the change in the situation, COVID, whatever is happening. We have complete certainty, like I'm telling you, I'm standing in front of you now. You can see 5 buttons in this chart. But if I stand at the edge of the road there, about 1 kilo from you, and told you 5 buttons, you will say, I can't see you even. How I will see the buttons? I can't see anything. Complete uncertainty. In between them is always, this is the focal of the decision-making point in the management, which is risk, a risk area. And the risk we used to put probability distribution, and by the probability distribution, we put something is called expected value, and you will put a number of values for your own decision. So you would say, as example, if it is mild, the market is mild, I would sell 100,000 for 30%. If it is deflation or recession, I will sell 10,000 units with a probability of 40%. So you put probability distribution for the area in the middle here. And most of the business decisions are here in the middle area, in the risk area. They are not in complete or incomplete. They are most of them in the middle area or the risk probability area. Let's go to share the screen now and watch out. What we have here about our work, and actually these lectures are very beautiful and the sources there. The decision theory, like we see here, we have decision analysis. What do we mean by the decision analysis? Techniques used to make decisions among a set of discrete alternatives, like we are saying in case of, or in case of, or in case of the face of the certain. Okay, like the investments, like the new products, like facility expansion. Look at all this, it's all related to the future, like you see here. And as long as there's something related to the future, then you cannot see 100%. You cannot talk that you are in complete certainty area here. No, you are not. And you are not also in the incomplete certainty here. You are not also here. You are in the middle or the area of the risk, this area, the area of the risk. Okay. What are the meaning of what we're talking about? There must be an important problem, of course, because when you deal with this kind of problems regarding the future, it's important. A unique problem or characteristics. Non-instantaneous decision required. It's something that is facing you like you don't have a ready-made template. It's a situation all is vague, and you want to find an answer and solution. Uncertainty, and this is the most important part. You cannot see clearly 100%. So we have here decision alternatives, and we will see it just now. In case it rain, I will come to see you 30%. In case it didn't rain, I will come to see you 70%. All of them are 100%. So this we call it alternatives. It's our choice because I am the one who will come to see you. So I decide when I will come to see you. Future events, it's in the future because if it rain, I will come to see you. I will. So it's a future. Define all, mutually exclusively, collectively exhaustive. The payoff is also the value of a decision of certain states, and we will see now how we will calculate these values, because we will translate what I'm talking in words into real formulas and into digits, and we will get a model for each case of states of nature. Okay, criteria for the evaluation of the alternates also. We'll see also the decision tree, and this is also one of the ways we take decisions in such cases when we have more than one alternate, and we will devote one lecture for the decision tree. Here is the figure of the decision tree. Just know it for the moment, and we will come to it later. You will understand it, totally understand. Now, the types of problems. This is very important. What are the types of problems? We have certainty. The certainty, the first one, like I told you here, I'm quite sure of everything. Know which outcome, states of nature will occur. I'm quite sure of what I'm doing and what are the results of what I'm doing. Hence, select best alternate. Okay. Uncertainty, no probability. This is one. There is no probability. The probability is in the middle, like I showed you here. The probability is only in the middle, in the risk. But uncertainty, there is no probability. Yeah. And no information, because uncertainty, it's totally after 15 years. You are planning for 15 years. How far you will decide the prices? You cannot know. Even the price will change tomorrow or day after tomorrow. So how about after 15 years? It will be very hard. It will be very hard for you to decide to check out for the prices changes or whatever. So you don't have information in the uncertainty conditions. Okay, the risk is here, like I showed you. This is the risk, the middle area. The risk here, the risk, this one, the risk is in the middle, like I showed you now on the screen, and its probability of outcomes. We said, if it rain, I will come to you 30%. If it didn't rain, I will come to you 70%. So here we put 30 and 70. We call it probability of outcomes, or probability that I will come to you or not come to you. Okay. So what about the decision under uncertainty? What we will do when decision makers does not know what outcomes will occur, has no probability estimates. For commonly used, they use those methods. The first one is called Laplace, or equally like. You give all the circumstances the same. We will see it now. It will appear to you practically more than just talking theoretically. Maximax, you think that the best situation will happen. In the maximax, you think that the best situation will happen, that the best of the best. You will have everything. Okay, it's very booming and very lighting. Okay, max min, this is conservative. Take the minimum of every row, then take the maximum of the minimum. The minimax, take the minimum of every row, then okay, regret approach, the same thing. Minimax also. So max, take the max of every row the last time. Last one, take the max of every row, then take the minimum of them. It's opposite to this. The max mini and the max mini and the min max, they are opposite to each other. We'll see it now. It will appear to you. Here as example, the decision under uncertainty, if we are using Laplace criterion, okay, I think I will write these numbers here on the board, and we will solve it together. Then we'll check out, we'll see how it works. I will make the screen. I will share the screen, stop sharing the screen, and I will write these numbers here right away. I will write these numbers. So let us go to it. And this is the first criterion, which is called Laplace. The first criterion, which is called Laplace. In Laplace, you don't know what is happening, so you will give the probabilities equally for all of them. So if I say I have decisions D1, let's see like this. I have D1 and D2 and D3. I have D1 and I have D2 and I have D3. This is Laplace. If I tell you solve based on Laplace, okay, the states of nature, I have S1, I have S2, I have S3. States of nature are the outcomes. So I will say here 10,000, 6,500, 10,000, 6,500, this is given, and minus 4,000. Okay. Then the second one is 8,000, 6,000, 1,000. 8,000, 6,000, 1,000. I would say what the meaning of this now. And 5,000, 5,000, 5,000. 5,000, 5,000, 5,000. This is in dollars. So mean this is the decision one. It will give the states of nature 10,000 in some cases, like as example, if there is the situation is mild, if there's decision, it will give 6,500. If there is inflation, it will give minus 4,000. So based on Laplace way, what we will do is, I will tell you, and Laplace, you will give the same equality or the same probability for all those solutions. Still, you are in uncertainty and you don't know the decision-making process. So what you will do, you will get the average of each one. The average of each one. As example, 10,000 plus 6,500 plus and minus, plus and minus will be minus 4,000. Then all this you will divide by how? 3, because you have 3 alternates. You will divide by 3. This will give you, in that case, this will give you 16,500 minus 4,000, 12,500, 12,500 divided by 3, because we said 3. This will be 12,500 divided by 3. We'll check out how much it will give me. Okay. Let's go for the calculator and check the calculator. We have here 10,000, 10,000, 10,000 plus 6,500 minus. I should make for you so that you see what I'm doing. Now I'm doing like this. Again, let me do from the start itself so it will appear to you. In Laplace, I'm working on Laplace criterion. So 10,000, the first number, 10,000 plus 6,500, 6,500 minus 4,000, minus 4,000. That will equals 12,500 divided by 3 times 3. That will equals, like what you see here. Look at this. Here is a number, 4.16, and he approximated the 7. He made the 7. Okay. So it will be 41.67. So this will be 4 equals 4,167. Of course, this is in dollars. Of course, this is in dollars. Second one, the same thing. I will do like this: 8,000 plus 6,000, 8,000 plus 6,000 plus 1,000 divided by 3. That will give me this 8 and 6 and 1. This is 15,000. 15,000 divided by 3 will equals $5,000. Again, I will show it to you on the monitor here. The second row or the second decision here, how I will get it? Also the same thing. I will go to the calculator. I will go to my calculator. Here we go. And I will calculate 8,000 plus 6,000 plus 1,000 equals 15,000. Those I will divide by 3. Why 3? Because I have 3 states of nature. I have 1. This is state 1 and state 2 and S3. So I will divide by 3. This will give me 5,000. Exactly. Here is the number. The 5,000 is here. Okay. So here I will stop share and I will show it back. I will show it back. I'm working on Laplace criterion, which I will deal with all the events, with all the states, give them equally the same importance. So 8,000 plus 6,000 plus 1,000 divided by 3, divided by 3, this will be 15,000 times 3. This will give me $5,000. So the first alternate give me the output of it, or the earnings or the profits, is $4,167, while the second one give me $5,000. Let's go to the third one. Third one is very easy because it's also 5,000 plus 5,000 plus 5,000 divided by 3. So this will be 15,000 also. 15,000 divided by 3 will give me 5,000. Here we go. Let us see here. Let us go to the example and see. Let's go to the example and see. Yes, 5,000 plus 5,000 plus 5,000, and divided on 3, it will give me 5,000. Now, how I will use? In that case, I have 3. Assume all states are equal alike. So here is the decision. I will, based on the decision here, I will take the highest number, and this will be the representative, which will give me the highest one, which is 5,000. So my criteria here, I will choose the highest number. Okay, so this is the first. Okay, this is the first case. Second case is what we will do about maximax, or we call it the optimistic. We call it the optimistic situation. The maximax, this is the new method, or the second method. Maximax means max of the max. Max of the max. So maxi, M-A-X-I. Let me remove this first so that the whole calculations won't bother you or won't confuse you. And we'll start now the criteria. You tell me, then what you will give me in the exam, how you will give it to me. I will give you the table, and I will tell you based on this. Here we go. I will give you the table like this table in front of you, and I will tell you choose the best alternate in one of the following criterions. As example, Laplace or maximax. So this is the second way. Now we are doing maximax. In maximax, what you will do, this is, we call it fully optimistic. Optimistic criterion. We call it the optimistic criterion, or optimistic. Optimistic. Okay, here what we do here. Optimistic means like I'm not looking to the cup or the glass that half the glass is empty. No, I'm saying half the glass is full. So what I will do here, actually it's very easy and very simple. You will choose the maximum in every row. Choose the max of every row. Okay, so G1, the maximum of G1 here, this is the max. The maximum of D1, the maximum of first one is 10,000, because this is the greatest number in the first row. It's 10,000. The maximum of the second row, 8,000, 6,000, 1,000. The maximum is 8,000. Perfect. Then for the third row, all are the same, so no problem. I will choose 5,000 because it's the maximum is the minimum. It's 5,000. Then you choose, first step, you choose the maximum of every row. Second, choose the max of max. Means what? The max of the column which you did. The max of the column which you did. So you tell me now, The max of the max here is how much? 10,000. Which is the largest number of them? It's 10,000. So here we go. Here we go. So I will choose based on the optimistic, or maximax. I will choose decision one. I will choose decision one because it is the max of all these numbers. The max of the column is more than 8,000 and more than 5,000. For that reason, I will choose the max of the max. The max of the max. This is the second criterion of decision making in the uncertainty. Thank you so much. Thank you so much.